Let's take a quiet journey through the solar system. There's no hurry. We have all the time we need. We're going to drift slowly from one world to another, learning a little about each place we visit. Everything is calm. Everything is still. We're just going to float gently through space and let the planets reveal themselves to us one by one. We'll start at the center, where everything begins, and then we'll move outward, slowly, peacefully, visiting each world in turn. The distances are vast, but we don't need to worry about that. We're simply going to let ourselves glide from one place to the next, taking our time, letting the quiet vastness of space surround us. So let's begin. Let's start where it all starts. At the heart of our solar system sits the sun. It's enormous, so large that if you could somehow hollow it out, you could fit more than 1 million Earths inside. But we're not thinking about numbers right now. We're just noticing the sun, feeling its presence at the center of everything. The sun is a star, just a star, one of billions in our galaxy, but it's our star. It's made mostly of hydrogen and helium, and deep in its core, hydrogen atoms are constantly fusing together to create helium. This fusion releases energy, an incredible amount of energy. And that energy travels outward, taking thousands of years to move from the core to the surface, and then just 8 minutes to reach Earth as sunlight. The surface of the sun is called the photosphere, and it's about 5,500 degrees Celsius. That's the part we see when we look at the sun, though of course we never look directly at it. Above the surface, there's a thin atmosphere called the corona, which is somehow even hotter than the surface itself, millions of degrees hot, though we still don't entirely understand why. The sun is constantly active. Its surface churns and bubbles. Sometimes great loops of plasma arc up from the surface, following magnetic field lines, and then fall back down. Sometimes there are dark spots on the sun, cooler regions called sunspots, where the magnetic field is particularly strong. These spots come and go in cycles that last about 11 years. But for all its activity, the sun is also stable. It's been burning steadily for about 4.5 billion years, and it will keep burning for another 4 or 5 billion years before it begins to change, to swell, to eventually become something else. But that's far in the future. For now, the sun is simply there, steady and constant, holding everything in its gravitational embrace. Let's move away now. Let's drift outward from the sun and visit the first world in our journey. Mercury. The closest planet to the sun is Mercury. It's a small world, not much bigger than our moon, and it's fast. Mercury races around the sun faster than any other planet, completing its orbit in just 88 Earth days. That's where its name comes from. Mercury, the swift messenger of the Roman gods. But here's something strange. Even though Mercury orbits the sun quickly, it rotates very slowly. It takes Mercury almost 59 Earth days to turn once on its axis. And because of the way its orbit and rotation match up, a single day on Mercury, from one sunrise to the next, lasts 176 Earth days. So if you were standing on Mercury, the sun would move very, very slowly across the sky. Mercury is a world of extremes. During the day when the sun is overhead, the temperature can reach 430 degrees Celsius, hot enough to melt lead. But at night, with no atmosphere to hold in the heat, the temperature drops to negative 180 degrees Celsius. The difference between day and night on Mercury is more than 600 degrees. The surface of Mercury is covered in craters, thousands and thousands of craters made by asteroids and comets that have crashed into the planet over billions of years. There's no wind or water to wear them away, so they just stay there, unchanging, marking the passage of time. Some of these craters are enormous. One of them, called Caloris Basin, is about 1,500 kilometers across. Between the craters, there are smooth plains. These might have been created by ancient volcanic activity, lava flowing across the surface and then cooling, and there are strange ridges and cliffs, wrinkles in the surface that might have formed as Mercury's interior cooled and shrank, causing the crust to buckle. Mercury has almost no atmosphere, just the faintest trace of atoms captured from the solar wind and temporarily held by the planet's weak gravity. So the sky on Mercury is black, always black. Even during the day you'd see stars, because there's no air to scatter the sunlight. We've only visited Mercury twice with spacecraft, Mariner 10 in the 1970s and Messenger in the 2000s. Both showed us a world that's ancient and quiet and scarred, a world that's been slowly orbiting the sun, baking in its light for longer than we can easily imagine. Let's move on now. Let's drift a little farther from the sun to the next world. Venus is the second planet from the sun, and from far away it looks beautiful, bright and white, covered in thick clouds that reflect sunlight brilliantly. Venus is the brightest object in our night sky after the moon. Sometimes you can see it just after sunset or just before sunrise, shining steadily in the twilight. People have called it the evening star or the morning star, though of course it's not a star at all. Venus is almost the same size as Earth, just slightly smaller, slightly less massive. And because of this, people used to think Venus might be similar to Earth, maybe covered in oceans, maybe filled with life. But when we sent spacecraft to Venus, we discovered something very different. Venus is the hottest planet in the solar system, even hotter than Mercury, even though Venus is farther from the sun. The surface temperature on Venus is about 470 degrees Celsius, hot enough to melt lead, hot enough to make rock glow faintly in the darkness. And the reason Venus is so hot is its atmosphere. The atmosphere of Venus is incredibly thick. The pressure at the surface is about 90 times the pressure on Earth. If you were standing on Venus, it would feel like you were underwater, deep beneath the ocean. And the atmosphere is almost entirely carbon dioxide, which traps heat. This is a runaway greenhouse effect. Sunlight gets through the clouds, warms the surface, and then the heat can't escape. It just builds and builds. Those beautiful white clouds that make Venus so bright are made of sulfuric acid, and they completely cover the planet, hiding the surface from view. The clouds are so thick that the sun, from the surface of Venus, would just be a diffuse glow in the sky. You'd never see stars from Venus. The sky would be a dim, yellowish or orange color even during the day. Venus rotates very slowly and in the opposite direction from most other planets. While Earth and most planets rotate counterclockwise when viewed from above the North Pole, Venus rotates clockwise. We call this retrograde rotation, and it's so slow that Venus takes longer to rotate once than it takes to orbit the Sun. A day on Venus is longer than a year on Venus. The surface of Venus is young, geologically speaking, much younger than Mercury or the Moon. It's covered in volcanic plains and large volcanoes. Some of these volcanoes might even still be active, though we're not certain. At some point in Venus's past, maybe a few 100 million years ago, the entire surface might have been resurfaced by volcanic activity. Old terrain buried under new lava. The exact details are still uncertain, but Venus is clearly a world shaped by volcanism. The Soviet Union sent several spacecraft to Venus in the 1970s and 1980s, and some of them actually landed on the surface. They didn't last long in the heat and pressure, but they sent back a few pictures. The surface is covered in flat rocks, a dim landscape under a heavy sky. A harsh world, hiding beneath beautiful clouds. Let's continue our journey. Let's move outward again to a more familiar place. The third planet from the Sun is Earth, home, the place where we all live. And from space, Earth is beautiful. Swirls of white clouds over blue oceans, brown and green continents, ice caps at the poles. It's the only world we know of that's filled with life. Earth is just the right distance from the sun. Not too hot, not too cold. Water can exist here as a liquid, pooling in oceans and lakes, flowing in rivers, falling as rain. And water is essential for life, at least the kind of life we're familiar with. Almost 3/4 of Earth's surface is covered in water. Our planet has a substantial atmosphere, mostly nitrogen and oxygen, which we breathe. This atmosphere is thick enough to protect us from harmful radiation and small meteorites, but thin enough to be transparent. We can see the stars at night. The sky is blue during the day because of the way sunlight scatters in the atmosphere. Earth is geologically active. The surface is broken into large plates that slowly move over time, driven by heat from the planet's interior. Where these plates collide, mountains rise. Where they pull apart, new ocean floor is created. Volcanoes erupt. Earthquakes shake the ground. The face of the Earth is constantly changing, though most of these changes are so slow we don't notice them in a human lifetime. Our planet has one large moon, simply called the Moon. It's about 1/4 the size of Earth, which is unusually large for a moon relative to its planet. The Moon formed early in Earth's history, probably when a Mars-sized object collided with the young Earth, and debris from that collision coalesced into the Moon. The Moon's gravity creates tides in Earth's oceans, pulling the water into bulges that we experience as high and low tides. Earth takes 365 1/4 days to orbit the Sun, and it rotates once every 24 hours, giving us day and night. The axis of Earth's rotation is tilted about 23.5 degrees, and this tilt gives us seasons. When the northern hemisphere is tilted toward the sun, it's summer there and winter in the southern hemisphere. 6 months later, the situation is reversed. Life on Earth is everywhere, in the oceans, on the land, even in the air. Tiny bacteria in the soil, vast forests, creatures in the deepest parts of the ocean, and of course, us, humanity. We're part of this planet, part of this story. We're made from the same elements as the rocks and the air and the water. We're children of the Earth, and the Earth is a child of the solar system, and the solar system is a small part of the galaxy. It's worth pausing here in our journey to appreciate this. Earth is special, at least to us. It's the only place we know of where life exists, and it's fragile, precious. We're here now, looking outward at the other planets, but we should remember the world beneath our feet. Let's move on now. Let's continue outward from the sun to the next planet in line. The fourth planet from the sun is Mars, the red planet. It's smaller than Earth, about half the diameter, and with much less mass. Mars is the last of the rocky planets before we reach the giants farther out. Mars gets its red color from iron oxide on its surface, rust essentially. The rocks and soil on Mars are rich in iron, and over time that iron has oxidized, giving the whole planet a reddish hue. From Earth, Mars looks like a small reddish star in the night sky, and that color has fascinated people for thousands of years. The atmosphere on Mars is very thin, less than 1% the pressure of Earth's atmosphere. It's mostly carbon dioxide, with traces of nitrogen and argon. Because the atmosphere is so thin, it can't hold much heat. During the day at the equator, temperatures might reach a pleasant 20 degrees Celsius, but at night, they plummet to negative 70 degrees Celsius or lower. And at the poles in winter, it gets even colder, cold enough for carbon dioxide to freeze out of the atmosphere and form ice caps. Mars has 2 ice caps, one at each pole. They're made mostly of water ice, covered with a layer of frozen carbon dioxide in the winter. As spring arrives, the carbon dioxide sublimates, turning directly from ice to gas, and the caps shrink. In summer, only the water ice remains. The surface of Mars is ancient and cratered in some places, but in other places, it's surprisingly young. There are enormous volcanoes on Mars. Olympus Mons, the largest volcano in the solar system, rises about 21 kilometers above the surrounding plains. That's more than twice the height of Mount Everest. But Olympus Mons is probably extinct now. It hasn't erupted in millions of years. There are also vast canyons on Mars. Valles Marineris stretches for thousands of kilometers along the equator, a great gash in the surface that dwarfs the Grand Canyon. And there are dry riverbeds, evidence that liquid water once flowed on the surface of Mars. Billions of years ago, Mars might have had a thicker atmosphere and a warmer climate. Rivers might have run, lakes might have pooled, but over time, Mars lost most of its atmosphere, and the water either froze beneath the surface or was lost to space. We've sent many spacecraft to Mars, orbiters, landers, rovers. They've explored the surface, analyzed the rocks, searched for signs of past life. We haven't found definitive evidence of life yet, but we've found conditions that could have supported life in the past, and possibly, beneath the surface, where liquid water might still exist, there could be microbial life even now. We don't know yet, but Mars remains one of the most intriguing places to search for answers. From Mars, the sun looks smaller in the sky, about 2/3 the size it appears from Earth. Sunlight is dimmer. It would feel like late afternoon on Earth, even at noon on Mars. And at night, you could see 2 small moons racing across the sky. Phobos and Deimos, tiny, irregularly shaped moons that are probably captured asteroids. Phobos orbits so close and fast that it rises in the west and sets in the east, the opposite of how moons normally move. Mars is the edge of the inner solar system. Beyond Mars, there's a gap, a region filled with asteroids, and then we reach a very different kind of world. Jupiter is the 5th planet from the Sun, and it's enormous. It's the largest planet in the solar system, more than 11 times wider than Earth. If Earth were the size of a marble, Jupiter would be the size of a basketball. Jupiter contains more mass than all the other planets combined. It's so massive that it almost became a star. But not quite. It didn't have enough mass to ignite fusion in its core. Jupiter is a gas giant. It doesn't have a solid surface like Earth or Mars. As you descended into Jupiter, the atmosphere would just get denser and denser. The pressure and temperature would increase. Eventually, the hydrogen gas would become liquid, and then deeper still, it would become metallic. Somewhere deep inside, there might be a core made of rock and ice, but we're not certain. We've never seen it. The atmosphere of Jupiter is beautiful. It's banded with different colored clouds, stripes of white and brown and red stretching around the planet. These bands are created by powerful winds that blow in opposite directions at different latitudes. Jupiter rotates very quickly, faster than any other planet. A day on Jupiter is less than 10 hours long. This rapid rotation creates fierce weather patterns with winds that can reach hundreds of kilometers per hour. The most famous feature on Jupiter is the Great Red Spot. It's a storm, a giant anticyclone, larger than Earth, that's been raging for at least hundreds of years, maybe longer. We don't know when it started. The Great Red Spot is slowly shrinking, and we don't fully understand why. But for now, it's still there, a swirling oval of red and white clouds in Jupiter's southern hemisphere. Jupiter has at least 95 moons, maybe more. The number keeps changing as we discover tiny new ones. But 4 of Jupiter's moons are particularly large and interesting. They're called the Galilean moons because Galileo discovered them in 1610 when he pointed his telescope at Jupiter. Their names are Io, Europa, Ganymede, and Callisto. Io is the most volcanically active body in the solar system. It's constantly being squeezed and stretched by tidal forces from Jupiter, and this generates heat inside Io, driving volcanic eruptions. Europa is covered in ice, but beneath that ice, there's almost certainly a global ocean of liquid water. Ganymede is the largest moon in the solar system, even larger than Mercury, and Callisto is ancient and heavily cratered. Jupiter also has rings, though they're much fainter than Saturn's. You can't see them easily from Earth, but spacecraft have photographed them. They're made of dust, probably kicked up by small meteorites hitting Jupiter's moons. From Jupiter, the sun is just a bright point of light, much smaller than it appears from Earth. The outer solar system is a dim, cold place, but Jupiter itself generates heat. It radiates more energy than it receives from the sun, heat left over from its formation and from the slow gravitational contraction of its interior. So even though Jupiter is far from the sun, its moons are warmed a little by their giant parent. Let's move on. Let's drift farther out to the next giant world. Saturn is the 6th planet from the Sun, and it's famous for its rings, the most beautiful, most spectacular rings in the solar system. From Earth, even with a small telescope, you can see Saturn's rings. They look like handles on either side of the planet, or like a hat brim, depending on the angle. Saturn is the 2nd largest planet, almost as big as Jupiter, but less massive. Like Jupiter, Saturn is a gas giant, made mostly of hydrogen and helium. And like Jupiter, Saturn doesn't have a solid surface. The atmosphere gradually transitions to liquid as you go deeper. Saturn also rotates quickly, with a day that's about 10.5 hours long. The atmosphere of Saturn is banded, like Jupiter's, but the bands are more subtle, softer in color, mostly shades of yellow and gold. Saturn has storms, too, but they're generally less prominent than Jupiter's. Every now and then, about once every 30 years, a massive storm erupts in Saturn's northern hemisphere, a giant white spot that spreads around the planet before eventually fading away. But let's talk about the rings. Saturn's rings are made of countless pieces of ice and rock, ranging in size from tiny grains to large boulders. Each piece is independently orbiting Saturn, creating the illusion of a solid structure. The rings are incredibly thin. If you were standing on the edge and looked at them from the side, they'd be almost invisible, thinner than a sheet of paper relative to their width. But they extend hundreds of thousands of kilometers from the planet. We're still learning about how the rings formed. They might be the remains of a moon that was destroyed, broken apart by tidal forces or a collision. Or they might be material left over from Saturn's formation. The rings might be ancient, or they might be relatively young, just a few 100 million years old. Different pieces of evidence point in different directions, and the question is still open. Saturn has more than 80 moons. The largest, Titan, is almost as big as Jupiter's Ganymede, and is the only moon in the solar system with a thick atmosphere. Titan's atmosphere is mostly nitrogen, like Earth's, but much thicker and much colder. The surface temperature on Titan is about negative 180 degrees Celsius. At that temperature, water ice is as hard as rock. But methane and ethane are liquid, and Titan has lakes and seas of liquid methane and ethane on its surface. It's the only place besides Earth where we found stable liquid on the surface of a world. Another interesting moon is Enceladus, a small icy world that's geologically active. Enceladus has geysers at its south pole that spray water ice into space. This suggests there's a liquid ocean beneath Enceladus's icy crust, kept warm by tidal heating, similar to what happens on Jupiter's Io. That ocean is another place where life might potentially exist. From Saturn, the sun is just a bright star. Daylight on Saturn would be dim, about 1% as bright as daylight on Earth. The ringed planet is almost 1.5 billion kilometers from the sun, nearly 10 times farther than Earth. At this distance, the solar system feels vast and empty. Let's keep going. Let's move to the 7th planet, a strange, distant world. Neptune is the 8th and outermost planet from the Sun. Like Uranus, it's an ice giant, slightly smaller than Uranus, but slightly more massive. Neptune is also blue, a deeper, richer blue than Uranus. This color also comes from methane in the atmosphere. But there's something else that makes Neptune's blue deeper. We're not entirely sure what. Neptune is the windiest planet in the solar system. Even though it's so far from the sun and receives very little energy, Neptune has incredibly fast winds in its atmosphere. Storms race around the planet at speeds up to 2,000 kilometers per hour. We've observed large dark spots on Neptune similar to Jupiter's Great Red Spot. These are massive storms. Voyager 2 saw one called the Great Dark Spot when it flew past Neptune in 1989. But when the Hubble Space Telescope looked at Neptune a few years later, that storm had disappeared. New storms have appeared since then. Neptune's atmosphere is dynamic and active. Why is Neptune so active when it receives so little sunlight? The answer is that, like Jupiter, Neptune generates its own heat. It radiates more than twice as much energy as it receives from the sun. This internal heat drives the weather, creating the powerful winds and storms. Neptune takes about 165 Earth years to complete one orbit around the Sun. Since it was discovered in 1846, Neptune has only completed one full orbit, plus a little bit more. From our perspective, Neptune is a slow wanderer through the stars. Neptune has rings, thin and faint, like Uranus's rings. And it has 14 known moons. The largest, Triton, is unusual. Triton orbits Neptune in the opposite direction from the planet's rotation. This is called a retrograde orbit, and it suggests that Triton wasn't formed alongside Neptune. Instead, Triton was probably captured by Neptune's gravity sometime in the past. Triton might have originally been a dwarf planet, something like Pluto, before it was caught. Triton is geologically active despite being so far from the Sun and so cold. Voyager 2 observed geysers on Triton, eruptions of nitrogen gas shooting up through the ice, and Triton's surface is young in some areas with few craters, suggesting that internal activity has resurfaced it relatively recently. From Neptune, the Sun is tiny, just a bright star, no different from the other stars except slightly brighter. Daylight on Neptune would be about 900 times dimmer than on Earth, more like twilight than noon. Neptune is almost 4.5 billion kilometers from the Sun, 30 times farther than Earth. Out here, the solar system is vast, dark, and frozen. Beyond Neptune, there's more, much more, but it's distant and cold and hard to see. Out here, we find a region called the Kuiper Belt, a disk of icy objects that extends far beyond Neptune's orbit. These are leftover building blocks from the solar system's formation, small worlds that never came together to form a planet. Pluto is the most famous object in the Kuiper Belt. Pluto was once considered the 9th planet, but in 2006, astronomers reclassified it as a dwarf planet. This doesn't make Pluto less interesting. It's still a fascinating world. It's small, smaller than our moon, and it's cold, with a surface temperature of about negative 230 degrees Celsius. But when the New Horizons spacecraft flew past Pluto in 2015, it revealed a surprisingly complex and beautiful world. Pluto has mountains made of water ice, some as tall as the Rockies. It has a large, smooth plain called Sputnik Planitia, shaped like a heart, which might be a slowly convecting layer of nitrogen ice, and Pluto has a thin atmosphere that freezes and falls to the surface when Pluto is farther from the Sun, then sublimates and returns to the atmosphere when Pluto gets closer to the Sun in its elliptical orbit. Pluto has 5 known moons. The largest, Charon, is about half the size of Pluto itself. They're so close in size that they orbit around a common point between them, not around Pluto's center. In a way, Pluto and Charon are a binary system. There are other dwarf planets in the Kuiper Belt. Eris, which is about the same size as Pluto, Makemake and Haumea, both smaller, but still substantial. And many more objects are waiting to be discovered, distant and faint, slowly orbiting the Sun in the darkness. Even farther out, beyond the Kuiper Belt, there's a vast spherical cloud of icy objects called the Oort cloud. This cloud extends maybe a quarter of the way to the nearest star. Objects in the Oort cloud are only loosely bound to the Sun. Occasionally, something disturbs one of these objects, and it falls inward toward the Sun, becoming a comet that we can see from Earth. We've traveled from the Sun outward through the solar system, from the blazing heat of Mercury to the frozen darkness beyond Neptune. We've visited rocky planets and gas giants and ice giants. We've seen moons and rings and storms. Each world is different, each one shaped by its own history, its own conditions. And yet they're all connected. They all formed from the same cloud of gas and dust billions of years ago. They all orbit the same sun. They're all part of the same story. Our solar system is just one small corner of the universe, but it's our corner, it's home, and it's filled with wonders. Rest now. Let the vastness of space surround you. Let the quiet distances between the planets calm your mind. The solar system will continue turning. The planets will continue their ancient orbits. And everything is as it should be. Sleep well